Hello, welcome to LeetCode Solver. Today we are going to solve 15th problem in May LeetCoding challenge. The problem name is maximum sum circular subarray. Given a circular array C of integer represented by A, find the maximum possible sum of non-empty subarray of C. Here the circular array means the end of the array connects to the beginning of the array. Formally, this property holds. Okay. Also, subarray may only include each element of the fixed buffer A at most once. Okay, we cannot take multiple times the same element. So input is 1 minus 2 minus 1 2 1 minus 2 3 minus 2. Output is 3. We are taking only this. Subarray 3 has maximum sum 3. But in this case, we are taking subarray should be continuous, but as this is circular, we may assume that there is something to the right side, like so. This is the maximum subarray sum, which is the concatenation of prefix and suffix value and like prefix 5 suffix 5. If we combine this, then we are getting 10 as the answer. So answer can be either in the somewhere in the middle, or answer can be combination of prefix and suffix. And another thing that I notice is if the answer is summation of prefix and suffix, then the elements that remains after taking these things is minimum subarray summation. This will be minimum subarray summation. If this is not minimum, then definitely the other values which were to the left side or right side could contribute to the maximum subarray summation. So remaining part should be minimum subarray sum. In case we take maximum subarray sum as a prefix and suffix combination. Otherwise, we can have subarray maximum subarray somewhere in the middle, or somewhere as a prefix, somewhere as a suffix, total suffix. Otherwise, if we have to take combination of suffix and prefix, then the whatever things, if we exclude minimum subarray sum, then we can get that. Let's go through other example as well. The output is 4, 3 minus 1, 2, 2, 4. This is as well prefix 3, 3 itself. Or 3 minus 2, 2. Here output is minus 1. So all the elements are negative. And for maximum subarray, we have to take at least one value. So that's why minus 1. Otherwise, it could be 0. So we have to include at least one element. So as I explained before, we can maintain a maximum subarray sum say initialized as first element, and we can also have minimum sub array sum, which is we can initialize as we have to take at least one element. Let's initialize with a0, and what we can have currents max sum. So we will be using Kadani's subarray maximum sum algorithm. So I will explain how it works. Before that, let's define current min sub, which is also a0, and we will be interested in calculating total summation, because in the case we have to take suffix and prefix, which can be retrieved by subtracting total summation with the minimum subarray sum. So let's total summation, as we are starting from one index, so on, now on, we can include a0 as well. Well, Kadane's algorithm, Kadane max subarray sum algorithm, how does it works? It works in a greedy manner. So what does it do is it's keep on calculating the current summation, say 1 2 3 5 2. It keeps on calculating these values from the prefix from the left side. As long as it is positive, if we have option to not, if in case we have option to ignore all the values, but as long as as we have to include at least one value, then if I keep on finding the summation so far, like 3 3 6 5 11 and 2 13, and something is there, like, so every time we will be maximizing the value. So far it is 13, and if we encounter something like minus 15, then if the total summation so far, if the minimum subarray sum so far, if the minimum summary sum so far is actually like, if we include this as well, what happens? It will produce us 13 minus 15, which is equal to minus 2. So if we include that, then if we get the element, like if we also want to include this and go along with 15 minus 15, then what happens, that the value we get here minus 2, so which is actually less than 0. And instead of taking this minus 2, uh, okay, minus 15 is also good. Let's go to minus 15, right? So answer so far is will be minus 2. It is also good, but what happens if I took another 2? Then it will make it 0. This is better than like taking minus 15, only taking minus 15. taking 2 is fine. So which is making it -2. Okay, and if I reach here, -2 and 2 combination will makes it 0. So it is not benefit for this 2 to become 0. Instead it could be 2 if it ignores all the values beforehand. So the maximum subarray sum prefix or ending at 2 is not optimal. Either I can start from the current position or I can continue whatever I have so far. So for 15th case, we see whatever it has so far. If I take with 15, it will make it -2. So which was good? Instead of beginning with -15, it may begin with -2. That's fine. It is actually reducing its value, but increasing its value. But if we go here, then we see that the previous is -2, and if we took 2 with -2, then we become 0. So 0 itself is smaller than 2. So if we find something smaller by taking this with previous one, then instead of going with that flow, it's better to start from the beginning from here. So it's better to directly start from 2 instead of taking 0, which will give us maximum Sauvage sum. So this is the Cathanese algorithm. So let's go through our problem to let's solve this problem. Our problem, we are applying Cathanese algorithm. So first of all, let's find current max sum. Let's add summation, and as I explained before, is it better to start again or go with flow? This is the question every time. So is it good to start from ith position or continue with whatever subarray sum it has so far? This is question every time we should ask. So which is basically current max sum if it is smaller than current value, then we should consider moving to start again. So which is current max sum will be restarted again, will be equal to AI. Now our task is to update max subarray sum, which is basically same as previous max subarray sum or current max sum. Now let's find for minimum. Let's edit current min sum, same as previous things. We will add the current min sum, and if we see that current min sum is greater than current value, it's better to refresh again to make it more minimum. And similarly max min sub array sum will be equal to minimum of min sub array sum comma current min sum. We have to find total as well. Now only the case like if we are finding this minimum sub array sum here is -6, and if we subtract total with the -6, then we have nothing which will give us true value. So in this case we have to return max sum which will be calculated by Kadernet's algorithm. Will show total sum is equals to mean sub array sum if it is total, then there is no scope per second option, so it's always the first option, max sub array sum. So no option left, otherwise we have option to choose between max sub array sum or what, total sum minus mean. Let's compile. Problem n is not defined. Well, accepted. So time and space complexity, and let's discuss time and space complexity. Time complexity is big of n, as we are iterating over the given elements only once, and for the space complexity we are not using any extra memory, so we can say constant. Yes. So thank you so much for watching this video, hope it helps you. If you have any comment or anything to say, please feel free to comment. See you in the next video. Bye bye.